So, okay, so now I want to introduce one simulator called TiltSpin. Basically, the simulator can run the MIPS32. Again, this is kind of the education-wise the user interface, and in order to be able to run this Spin assembly language, and this will give you some idea about how and really when you run the how the really the registers value change or how it's overall implemented during the time when you implement this MIPS 32 assembly language. I hope this can give you some visualization, better feeling about the assembly language. So again, the you're allowed to download this open source simulator from this website. It's free, and here I already downloaded. So I just show you something. Okay, so basically when you see here, so let's first just go through a few slides and then I'll give you a demonstration. So basically, after you open, you will find this user interface, and this part is basically register visualization. You will see all the individual registers. For example, program counter, right? We talk about that, and then the register 0 until the register 31. And if you look at here, the this is the index of the register, and here's the name of the register. Many of them we are already familiar with, right? Like V0, V1, A0 until A2, A3, right? And also here and the T and here is like a T0, right? Until T7, and later will be T9, T8, T9, and here is S0 to like the other saved register, right? And then here will give you the program code, and here is a message. Okay, so again, and just here just some emphasize there's a program counter, rather exception program counter we will talk about in the future. Basically, that is the implement the exception handling. What means exception means something happened which is not expected, some unexpected result happen, right? Some error occurred. So how we deal with that, we will leverage this exception program counter. We will talk about in the future. And here is the high and the low. And we will also talk about that when we talk about the division and multiplication. Here is the general purpose register I just mentioned. And here I want to mention basically the code we write is within here, and the before is kind of a globalized initialization. So as long as we plug our code in, our code will be in this procedure. So let me just give a more example and see demonstrate one better. So let me see. Okay, good. Just put here. Okay, so all right. So basically, you can write the code, and you can write the code using any editor, and then after that, all you do is you just need to save that code and with the file like a .asm. As long as you save that with a .asm will be good. So if you look at this code, there's an example. So basically here is some format. So basically you always need to mention, in order to interact with the global code, as you mentioned, here is the main, right? Global main text. And then beginning from main will be the one and will indicate your procedure will start. Okay, so this is a keyword you have to implement it. Okay, and then after that you will begin to this part. Basically is the part we will run for our own program. You can see what I have here. I do is I try to calculate as some value stored in T0, some value stored, like for example, a high level variable A is stored in T0, high level variable B is stored in T1, and then I want to calculate F equal to A plus B, right? And then F I enforced to store in S0, right? That's the same example we mentioned in class. So in that way, because S0 is a preserved register, and this procedure is the leave procedure, so I need to push the original value of S0 into the stack, right? That's why I need to adjust the original value of stack pointer and then store our original value of S0 into the stack, and then implement this A plus B equal F equal to A plus B, right? So basically, I set the value of T0 as 4, set the value T1 is 5, indicate A is equal to 4, B equal to 5, and then implement the addition as equal to S0 equal to T1 plus T2. And then the return value V0 is stored or contain the original value. Sorry, say one more time. V0 will be set as the value of S0 because that is the value I need to return out, which is F, right? After that, I will do the load word and add immediate on stack pointer. Basically, I pop the original value of 0 from the stack point. Say one more time. Basically, I'm using load word and add immediate to pop the original value of S0 from the stack, and then I will do the jump and the return. Okay, again, all these things you have to include no matter what kind of code you want to write. And here is the main code you want to write. And then after you finish, no matter what editor you use, you just store that with the name of your code and .asm. Okay, if it is okay, so I just give an exam demonstrate. So here I can initialize. Initialize means I initialize this software and store and open the code. I just show you. So let's add ASU. So you can see here basically our code is stored in here or plug in here, right? As I mentioned before, it's all the global code, and here is our own code. Okay, after that, you can see the all those registers value are initialized. And then when I try to implement one after another, you can see here, actually one thing I just want to mention, you can select what kind of base you want to use to represent the value of your register. For example, I want to represent my register value using the hexadecimal, which is consistent with show here. You can use a hexadecimal. Otherwise, I can use in the decimal. Okay, so I just using one hexadecimal to a little bit to show you or help you to visualize the how to change the program counter. Okay, you can see now the program counter is equal to 40004. The reason is I'm implementing this instruction now, and this instruction's memory address is 40004, right? And if I implement next instruction, you can see I put this program counter at 4, right? And then continue, you can see this register program counter also add another 4, okay? So now I just change to decimal. So in that way, it's straightforward to see how we implement this addition very soon. So here, just continue to implement the global code. After that, you can see here is basically just implement jump and link, right? Because a jump and link will jump to the first instruction in my code. Okay, so now basically you can see this program count is not match this value. The only reason is this one using the decimal, and here using hexadecimal. Okay, so after that you can see I begin to add the return address. Say one more time. Sorry, the stack pointer. Make a stack pointer is -4, right? So you can see here the stack pointer here, right? And then after I implement, you can see it's a -4. Basically, I bring the position of stack pointer lower in order to give me enough space to store one word in the stack, right? After that, you can see I will store the original value in S0 into the stack. Okay, and then now I will set the value T0 as 4, right? Because my high level variable A is in T0. You can see here will change to 4. And then I will set my T1 value as 5. You can see here set 5. After that, I will implement S0 equal to T0 plus T1, which means supposed to be 9. Let's see whether S0 will change to 9. You can see here change to 9, right? After that, I began to load the original value of T0 from the stack into T0, right? So you can see after I implement that, but I skip one more. This line is mentioned is I set the value of V0 into or as the value of T0, right? If you look at here, your V0 is 9 now, right? Because V0 supposed equal to S0 now. Okay, after that, here is I pop the original value of S0 from the stack. So you can see, after doing that, you can see the original value S0 replaced, right? The original value of V0 is loaded. And then after that, I will do a jump and return and then finish. Okay? I hope this is give you a clear idea, and I will upload this code into our Brightspace for you can play with. Okay.